Welcome to TypeSpec 101. My name is Mario Guerra. I'm a product manager at Microsoft responsible for TypeSpec. Through this series of videos, I'm going to walk you through the process of defining a REST API in TypeSpec and teaching you the basics of the language. In this first part, we're going to set up our environment and cover the basic syntax and structure of TypeSpec. If you'd like to follow along with the tutorial sessions, you can download the session files from aka.ms/typespec101/files. This will give you access to the end result of changes made to main TSP for each video. You can easily cut and paste from these files to follow along and implement the changes as we go through the tutorials. So what is TypeSpec anyway? It's a language and toolset developed at Microsoft for defining service APIs using an API-first design and development approach. Within Microsoft, we're using TypeSpec to define the API interface for various products and services, including Microsoft Graph and Azure. Let's get started with setting up our development environment. First things first, you'll need to have Visual Studio Code installed if you want to follow along. You can download Visual Studio Code from aka.ms/VS Code. You're also going to want the TypeSpec extension for Visual Studio Code, which provides syntax highlighting, IntelliSense, and other helpful features. You can find it in the Visual Studio Code Marketplace by searching for TypeSpec, or go to aka.ms/typespec-VS Code. You'll also need to install Node.js version 20. If you don't already have that installed, head over to nodejs.org and download it. Once you've installed these tools, open Visual Studio Code, open a terminal, and type npm-version. This will check if npm is installed correctly. You need to be using npm version 7 or higher. Next, we need to install the TypeSpec compiler and command line interface. You can do this by running npm install @typespec/compiler. Okay, now we're ready to create a new TypeSpec project. In a clean directory, run tsp init. This command launches a simple project creation wizard that will prompt you with a few questions. Choose the generic REST API template, confirm your project name, and make sure the HTTP, go ahead and select the git ignore or not, depending on your choice, and make sure the HTTP and OpenAPI 3 libraries are selected. We don't need anything out of the REST library for this project, so you can deselect that one. After the project creation wizard is done, install the required dependencies by running tsp install. Once the dependencies are installed, you can run tsp compile to run a build and generate some output. You can also use tsp compile --watch to automatically compile changes as you save, which I recommend you do for this tutorial. At this point, you should have a basic TypeSpec project set up. Your directory structure should look something like this over here on the left. Main TSP is the entry point for a TypeSpec build, where we'll define our models and operations. TSP config YAML contains configuration information for the TypeSpec compiler. Package.json lists project metadata and dependency. The Node modules folder contains the installed dependencies. The TSP output folder is where generated files show up. OpenAPI.yaml is the OpenAPI specification generated by a build. I suggest keeping this file, the OpenAPI.yaml file, open to the side so we can watch the API spec evolve as we make changes. Now that we have our environment set up, let's dive into TypeSpec. Before we do anything else, we need to make sure we're importing the necessary TypeSpec libraries and make them available in our project. Open the main TSP file if you don't already have it open, and let's review the import and using statements. The project creation wizard has helpfully added the libraries we chose in the setup wizard. The import statement brings in the TypeSpec HTTP library, which provides the decorators and models we'll be using to define our REST API. We also need to add a using statement to make the imported library available in our project context. Although we need the OpenAPI 3 library for generating the output, we don't actually need anything from this library for this tutorial, so let's remove references to it. Now let's define a REST service. In TypeSpec, we use the service decorator to specify metadata about our service, like its title. We can also use the server decorator to define the server endpoint where our service will be hosted. Let's start by defining a simple REST service for our pet store. In this example, the service decorator gives our service the title Pet Store, and the server decorator specifies the server endpoint as example.com. Now, this won't actually build yet because we've not defined a namespace for these decorators to apply to. We'll get to that next. Namespaces in TypeSpec help you organize your models and operations logically. They act as containers for related definitions, making your API easier to manage and understand. Let's create a namespace for our pet store service. Here, we use the namespace keyword to define a top-level namespace named Pet Store. All models and operations related to the pet store service will be defined within this namespace. This is the top-level namespace, so we don't need to use any brackets. Eventually, we'll be defining nested namespaces within the top-level pet store namespace, so when we do, we'll use brackets to indicate that they are nested. In TypeSpec, a model is a fundamental building block used to define the structure of data. Models represent entities, like a pet, with various properties that describe the entity's attributes. Let's define a simple model for a pet. In this example, we defined a pet model with 4 properties: ID, name, age, and kind. We also defined an enum called pet type to specify possible values for the kind property. To make our models more robust, we can add validation annotation. These annotations enforce certain constraints on the properties, which you can see in the generated OpenAPI specification. Here we add min length equals 1 to ensure the name property has at least 1 character. We also add min value 0 and max value 100 to ensure the age property is between 0 and 100. You can see how these attributes translate to the OpenAPI specification. To be clear, your backend service code will actually need to enforce these constraints. I'm only showing you how to specify them in your TypeSpec code so they show up in your API spec. In this section, we've introduced you to TypeSpec. We've set up the development environment and covered the basic syntax for setting up a REST service. We've defined a simple model with validation annotations. We specified a REST service with a title and server endpoint, and we organized our API using namespaces. In the next section, we'll add CRUD operations to interact with our pet model.